Hello, it's Andy here, and welcome back to my walkthrough of the 2019 Sans Holiday hack. In the previous episode, we discovered that it was the dastardly Tooth Fairy who had been holding Elf University to ransom and threatening to destroy Christmas. Upon entering the sleigh shop, we find the Tooth Fairy, who seems pretty annoyed at being busted, but she's already managed to sabotage Santa's sleigh's guidance system by feeding it poisoned weather reports. Our final objective is to filter out the malicious weather data so that the system can operate normally and let Santa deliver presents on Christmas Eve. We also find one also has a terminal challenge for us too, involving the analysis of Zeek logs. It doesn't sound quite as urgent as saving Christmas, but it will give us a little practice at using JQ, which is just what we'll need in order to foil the Tooth Fairy's plot. He wants us to identify the destination IP address which has the longest connection duration. We have 48 megabytes of connection logs. Examination of the file with head shows one entry per line, and it's quite difficult to read. Let's just look at one event formatted nicely via JQ. We see a duration field. This is what we're after. We need to find the entry with the longest duration, so a query like this would provide the results. It looks like the longest connection is to 13.107.21.200, which we can submit to complete the terminal. For the main objective, we'll need to process another Zeek JSON file to identify malicious traffic, and then add rules to the sleigh route finder's firewall to block those bad hosts which are sending poisoned weather data. We were told by Kent that this system is using its default credentials. The document we decrypted in Objective 10 is the manual for this device. It doesn't provide the credentials itself, but does state that they're stored in a README file on the ElfU Git repository site, but fails to give the specific location. Perhaps we can find the location in the connection logs provided as part of this objective. First, we'll need to get an idea of what fields we have to work with. Okay, so these logs record host names. Let's look for any referring to Git. The test statement allows us to specify a regular expression. Here we're applying it on the host field. The additional I parameter specifies a case-insensitive comparison. No results are returned. How about where Git is in the URI? Wow, there's loads of them. On closer inspection, these mostly seem to have a 404 response, file not found, so let's filter those out. And we go back to no matches. We were told the details were in a README file, so we could just try searching for that. And we get a hit on a readme.md residing on the sleigh route finder host. Opening this location in the browser reveals the default credentials for the site. Once inside, we see some details about the system's API, followed by a map showing the current weather situation. It looks like the Tooth Fairy's plan has worked because the system is showing extreme weather across most of the globe. A little further down is the firewall interface, where we can add specific hosts or networks to accept or deny traffic from. This also confirms that the system is not able to calculate a route for Santa's sleigh due to erroneous weather data. So, let's get hunting for that malicious traffic. We already examined some of the fields available to us, but another which will likely be useful is the user agent field. Let's start there and get a list of all the unique user agents and see if there's any that immediately jump out as suspicious. We're getting far too much data by having the whole record returned for each match, so let's ask for just the user agent field. That's better. There's traffic reportedly from lots of different versions of Opera, and Mozilla, and a few spiders and bots, and some very obvious SQL injection and attempts at reverse shells. Starting with SQL injection, what records have a user agent containing the word union? Again, we're getting a lot of data returned, whereas really we're just interested in what IPs those requests originate from. These are all clearly malicious hosts and can be noted down for blocking later. Here I'm using JQ's -R option to remove the quote marks from the output and storing it in a file called bad IPs. All the reverse shell attempts have /bin/ in them, So let's use that as the search string to identify the source IPs for these requests to add to the block list. Whilst we're on the topic of user agents, any blank user agent would also be suspicious, but it doesn't look like any are present in the dataset. So that's some SQL injection and shell injection found in user agent strings, but normally this sort of thing would target input fields via get or post parameters. The dataset contains both get and post requests, but post data itself isn't captured. It does, however, record input data for get requests in the URI field. So let's check that for SQL injection and shell injection. A search for the union SQL keyword brings back a bunch to block, so we'll add these IPs to our naughty list. Applying a similar tactic to identify reverse shell attempts on the URI field throws back many things that appear to be generic scanning activity rather than actively malicious. But there is one clear attempt at local file inclusion, so let's dig a little deeper. Are there any other attempts to grab the local password file? There's quite a few, so we'd best grab the IPs to block. Extending the search to look for any further occurrences of ... or cat just returns results we've already seen and captured. The other type of vulnerability Alabaster was worried about was cross-site scripting, so let's see if there's been any attempts to embed tags in any input fields. There's definitely bad stuff there, so we'll grab the IPs. This search for the obvious low-hanging fruit has netted 56 unique IPs which are malicious. Now, to dig deeper, let's understand the data better. Are all of these requests relating to a single destination host or web server? Yeah, looks like they are. What about the target host field? That should either be a valid IP or srf.elfu.org. Well, there's certainly a few suspicious items there. We'll make a note of the IPs associated with any of those cross-site scripting checks, and also the requests to the misspelt hostname. There's now 69 unique malicious IPs on the naughty list. It's probably about time to pivot. The most useful field to pivot on is likely to be user agent, as this is most likely to be retained by a particular attacker or piece of malware. We can build out a list of potentially bad user agents with a variation on the commands we use to capture the bad IPs. There's a stack of user agent strings that don't look right here. Some are trying to do shell insertion, but we've already captured those. Some, like HTTP browser, Rook IE, and Chol DB agent, are known to be used by various strains of malware, as mentioned in a Sigma rule on GitHub. That same rule calls out a specific wget user agent string, which is also found in our dataset. One user agent string mentions the exploitation framework Metasploit, so that can certainly get added to the naughty list too. Closer inspection reveals a stack of typos too. MSIE with a lowercase e, window rather than windows, one of which has a number 1 instead of an I, MSIEE with an extra e, tridents with an S rather than trident, missing spaces, missing brackets, Internet Explorer version 666, Gogglebot instead of Googlebot, and several more. We can add all the IPs using these dodgy user agent strings with one big regular expression. How big is the naughty list now? 100! That's exactly what we're aiming for. Let's feed those IPs into the slave route finder firewall. And success! The system has been able to calculate a route now that we've stopped the poisoned weather data. We've successfully thwarted the Tooth Fairy's attempts to destroy Christmas. We're given the route ID, which is the flag we need to enter into our badge to complete this final objective. This also unlocks the door to the bell tower, at the top of which we find Santa and Krampus, along with the Tooth Fairy, who is now donning a lovely orange prison jumpsuit. We're given a good pat on the back from Krampus and Santa, and the credits roll on the closure of another amazing holiday hack. Thank you to all these lovely people for the hard work and effort that has gone into making KringleCon 2 such a fantastic, enjoyable and educational event. We finally get to read the entirety of the narrative, which ends with a rather ominous mention of troubles to come next year. And what is this lying in the corner of the bell tower? A note from the Tooth Fairy saying that she had an accomplice for her evil plan, none other than Jack Frost. So, whilst we may have saved Christmas 2019, it looks like trouble is already brewing, and Santa will probably need our help again next year. I'll see you there.